Hello viewers, this is Almoran, aka Don Halloran. I am a Chief Software Engineer, Architect, Database Administrator, for those not in IT, a Programmer. And none of that is at all relevant because today we're going to be doing some advanced rocket ship design. So what I'm going to be showing is a demonstration of the thrust plate from my previous video. People wanted a bit more information on exactly what was going on there, and me showing off a heavy lift apparently did not really provide that much useful information. So first let me describe briefly the problem we're going to try and solve. Here is my payload. Let us imagine that this is something very heavy, or perhaps just something that's very awkward. We'll get to that as well. It is exerting a lot of force downwards through the central stack. In order to lift something very heavy, you need a lot of engines, potentially a lot of mainsails, and you can't just keep building below your payload because you can't fit more than one mainsail on a stack, so you have to start building outwards. And the problem is these mainsails on the outside are putting a lot of force upwards, and in the middle is a lot of force downwards, and you get very large shear stresses on your radial decouplers, and it means that your outer stacks have a tendency to tear off the rocket. So in order to build the thrust plate, you're going to need pretty much just the pieces that you see here, some 1x1 structural plates, some I-beams, and some of these little weenie decouplers. You'll see why I'm only using those ones in a moment. So start off building the plate, attach the I-beam to the central panel and the extra panels to the outside. Now I actually have the Editor Tools mod installed, which just makes building things a little bit easier. For example, vertical snap means that these plates, which would otherwise slide up and down, are locked to the center of the height of the I-beam, which means they're perfectly aligned with that one. So this is an OCD thing, but it also has a useful purpose, which I will demonstrate in a moment. Get your decouplers, attach them to the bottom of the plates, like so, and then build your stacks onto those decouplers. And you'll notice that for once, and this is rare, the part sizes work out very nicely, such that the plate plus the short I-beam plus another plate, or just about perfectly matches the width of two orange tanks with a slight gap in the middle, which is what you want, so you can safely decouple and eject your stacks. So what has this accomplished? Well, now your columns, which were previously liable to tear off because there was nothing above them, are constrained by the structural plate above them, which is very, very strong. These joints just don't break. I'm sure someone can figure out how to break them, but they don't break easy. Now these little weenie decouplers may not look strong enough, but it's very hard to destroy a part by compressing it in KSP. I don't even know if it's possible. If you're worried, you can of course add a few struts from the plates down to the stacks below. It does help with stability a little bit, and you can just keep going with this. My 750 ton payload rocket, I think, went out to this far, to 3 plates out, if you like, and then I did have one more stack attached to the side, kind of like that, and you can see that in the previous video. Now I also strutted between the plates like so, because triangles are an engineering golden rule, and that probably helps as well. And you can also strut from the plates to your payload. Now you could have strutted from the tops of the stacks to your payload as well, like so. Well, if I could get there we go. But of course these struts are going to go away when you drop your outer columns, and now your payload is going to be wobbly. So the other thing that the structural plate provides is a very wide base to strut your payload to, And that can be very useful if you have, as I mentioned at the start of the video, a very awkward payload, something which is really part of a space station, so it's maybe very wide, like this. If I can get that on there we go. Maybe you're building a ring and you want to launch a ring all in one piece, because building rings in orbit is difficult. But once you've dropped all your stacks, you end up with this one rocket right in the middle and this big wide payload above it, and it's wobbling all over the place. Well, having the thrust plate allows you to have a very nice wide strutting base as well, and you can of course also strut from your central column to these arms, and depending on exactly how you design the plate, you can actually get the struts out quite wide. On my original rocket, I actually used the long I-beam as the first joint, so I could get some narrower LVT-30 columns in there as well, because I just needed the extra thrust. And that will also fit very nicely, as you'll see in the have seen in the previous video. Now, while I'm in the VAB building stuff, let me show you a couple of other little tips. You should never do what I've done here. You should never attach a mainsail directly to an orange tank. Apparently not everyone knows that the mainsail is overheating because the orange tank does not conduct heat away properly. Now, that problem can be solved, or both of those problems can be solved at once if you're attaching mainsails to orange tanks, which most people usually are, by just throwing a little cubic octagonal strut to the bottom face of the orange tanks and then attaching the mainsails to those. Now let me show you another VAB construction technique. This is the multiple docking construction technique. So I get my docking port, and I'm actually going to build the stack beneath a pair of docking ports which are connected. I have another octagonal strut at the other end of this orange tank, and I actually need a copy of my structure from above, which I will attach to there, and I actually don't need that. I'll just turn these over. Like so, and I'll put the orange tanks, and you can see this is starting to look like the payload I launched, although it had another layer on it. Now I'm actually going to get some more docking ports. Let me just take this off so they're easier to attach, like so, and put this back on. And I'm going to attach 6 more docking ports to the tops of these orange tanks. Now the actual node construction goes down through the center, out and back up, just the way I built it. So when I attach these additional docking ports into those gaps, they'll be attached to the orange tanks but not attached to the docking ports above them. But when the rocket is launched, physics will kick in, and these two ports, being perfectly aligned with each other because of the way we've built this center stack, will immediately dock and provide some extra structural strength. You'll form a closed structural loop, which is something that you can't do in the VAB because of the way the part tree works. Now you could also just strut like this. You could just strut and not put the docking ports in at all. But I think that looks kind of ugly. Having the docking ports in, for some reason, it just seems nicer to me. I also wonder if it actually provides a little more structural strength than struts alone. So that's why I'm doing that. Now you might find when you try and put these in, they're difficult to connect. Oops, I haven't. Yes, I have. Vertical snap. There we go. See the Editor Tools mod coming in handy. Now you might find when you put these in, that actually went in quite nicely. You see it doesn't want to attach to some of them, and we'll solve that problem. There we go. But it can be hard sometimes to get this one in here. It wants to attach to the docking port above and to the structure below, and it might start jumping up and down and doing weird things like this and not going where you want it. Easy solution to that. Take your center off and put just something in the middle temporarily. Now attach your docking ports and get rid of that separator you added, and voila, that was easy peasy, no problem with the editor. So there's the multiple docking. Those will all attach. You've got your closed loop. Here's our thrust plate at the bottom. I can extend that, I can strut it all together, and this is quite a heavy payload. It's not ridiculously heavy, but it's heavy enough for most people to get started with, and you'll find that you'll have no problems with your rocket's structural integrity. Now you will still need to, after you build your stack below it, I won't do the whole thing here. Well, I need something so that this doesn't clip, so I might as well add the correct part in. You'll find that if you build multiple stacks, if you have another layer of this out like this, something like that, that looks a bit silly, but you probably will need to do a little bit of strutting, perhaps from there to there. Certainly if you are building further down, because of the nature of orange tanks like this, you will need to strut like that between the tanks, and you may also want to strut near the bottoms of your columns, because otherwise this will tend to flop a little bit. The structural plate isn't going to prevent it, or the thrust plate isn't going to prevent the bottoms of your rockets from wiggling around. What it prevents is the rocket from tearing off its decoupler because of the amount of thrust, especially if you're using asparagus staging, where your outer columns will become very light. Your inner columns are still very heavy, but they all have mainsails at the bottom, and that radically increases the shear stress between the outer and the inner column. So you will want a couple of struts in there, but you don't need to go completely crazy with the struts. This will really stand up to a lot of force. So enjoy building your ridiculous rockets with enormous payloads, and I hope you enjoy the technique.